Okay, so let's move on to our AES example. AES, it stands for Advanced Encryption Standard. So the one that we just looked at was data encryption standard. So we will do our next example in two classes. So our first class is my AES app. No main method. We're gonna use this class in our next class. So that comes from Java X.crypto package, which is your JCE class, because that's your JCE package. We will also create a private static byte array to hold a key. So advanced encryption standard. Advanced encryption standard. So first of all, let's set our key through a method public static void set key. To which we will pass the key that we want it to use. And the key object, or key array of bytes that I created on line number 12, will receive the my key and will convert it into bytes on the UTF-8 format. Now, there are a few terminologies that I want to explain to you guys. But prior to that, let's put this in a try-catch block. Okay. So the error from line number 16 will disappear as soon as we write a statement in the try block that this becomes reachable. So unsupported encoding exception is the one that is required for line number 13, where we are generating the key. Okay. Now comes some concepts. One of the concepts is checksum. Are you guys familiar with what is checksum?
It's usually like you add up all the bytes in you add up all the bytes in an array of bytes.
It's
And then the
basically
checksum is that sum at the end. And if some data got screwed up along the way, that checksum would not match.
exactly. So it's an error detection method to make sure that everything from one end matches with everything on the other end. So we have the other thing to learn is called hash function. It is a function to produce checksum. You guys know what we mean by the word hash?
I don't think so.
Okay.
Like, I know what it is, but I don't know what it means.
Okay. So what exactly is a hash value? It is a numeric value of fixed length that uniquely identifies data. So that's what a hash value is. Then comes another concept I want to talk about here. The concept of message digest. Have you guys heard of that concept before? Message digest?
I've heard it, but I don't know what it is.
It is a fixed size numeric representation of the contents of the message. Computed by who? The hash function. That's why I wanted you to understand what hash is. So that's what message digest does. It computes that hash value. So in Java, message digest class provides functionality of a message digest using algorithms such as SHA-1 or SHA-256. And what is SHA? SHA stands for Secure Hashing Algorithm. So much to know before you even can start coding, right?
Yeah.
Yeah.
So now we will start out with our message digest object. So message digest will now be used to tap into one of these algorithms by calling get instance SHA-1. Then using my message digest, I will create the digest, which will become my key. So I'll use what was passed by the user. So the user is controlling what key to pass. So the user passes a key into set key, which is used to generate bytes. And I'm using those bytes to create a digest and then giving that to my key. So now I'm using the arrays class to generate a copy of key. So I'm basically creating this new length of 16 bytes. So the original is the first parameter, and the new length is the second parameter. So that is my new key. And I'm using my secret key object of secret key spec type to now instantiate it on the key that is generated on line number 24, and I will be using the AES algorithm. So after setting the key, we now need an encryption method, which will help us encrypt the data. And then we will need a decryption method, which will help us decrypt the data. So public static string encrypt. String to encrypt. That's the string that I'm passing. And my key information is coming through. Oops. Public. So the first thing I do is when I start my encryption is to set my key by calling the set key method based on what I received as a secret key. Then I open my cipher object to now create a cipher instance. If you remember in the previous example, we did something similar, right? In the previous example, let's go back to it. What did we do? We created our cipher on DES, ECB, PK, CS5 padding. So instead of DES, I will now use what?
AES.
Exactly. And like in my previous example, right after that, I have to initialize the cipher in encryption mode. So I will do something very similar here. So we will have our cipher dot initialize the cipher in encryption mode on the secret key that we created right at the top and instantiated in the set key. And it is supposed to return the encrypted text. So now we're going to return the encrypted text. Base 64 system is what I'm using. So I'm going to be using the base64.get encoder to encode to string the cipher.doFinal, which is the same method that we used in the previous one. Cipher.doFinal. Okay, so cipher.doFinal will receive this string to encrypt and we'll convert it to bytes. And on the UTF version 8 here.
Yep, I'm all good.
Okay, now let's copy this entire method and paste it right below. We're going to call this one decrypt. Okay. It will still be setting the key. It will still be ciphering the instance. The difference will be it will now be on the decrypt mode. And the return statement will be a bit different here. Okay. So, because now we have encoded text. So we will be decoding it and then returning back the string. So we'll take the ciphered text dot do final which will have base 64 dot get decoder, because we're decoding, it's a backward process, to decode the string to, oh, I should change this parameter to string to DEC for a more meaningful name. That's about it. Nothing else. So that's what it does here. So it just ciphers and returns it back. Okay, so now we will be writing our next program whenever you're done with this one, which will call this class. Now let's create our next class, which we will call JCE example number 2 with a public static void main. So here, first of all, remember we have to pass a secret key. So let's come up with a secret key here, which I'll call secret key. And this is one of the advantages, is that you can create a very complicated secret key. So if you really, really want it to go very complicated, you can actually create an encrypted key. So they're going to do a double digest or double encryption. You know, your key is encrypted and then your message is encrypted. Okay, so, you know, you can do that, but I'm just using plain text here. Do not speak about this. That's basically my secret key. Okay. String original. Okay, so I'm just creating a random string over here called secret site. HTTP 10.67.84.101. Okay, so this is basically all plain text. Now I got to encrypt the text, then I got to decrypt the text, and then I will display all. So this is the 3-step process. So encrypted site. What is the name of my class? My AES app. And notice all the methods are static. So I do not need to create an instance of the class to call the methods. So AES, oh, sorry, my AES app dot encrypt, to which I will pass the original string as the first parameter and the secret key as the second parameter. Let's test to see how it looks like at this point. So this is my original text. And then I have my encrypted text. Okay, let's see how this looks like. Okay, see that? Now let's create a string for decrypted site. So my AES app dot decrypt. So what are we decrypting? We are passing the enc site, and we are also passing the same secret key. So as long as you use the same secret key, you can encrypt, decrypt on a much better algorithm, the AES algorithm. So now we are displaying the decrypted text. Okay. And now let's run it. Yeah, the same thing back. Cool, right?